With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, if we define a quantity linear momentum as linear momentum equals mass into speed. So we know the formula for linear momentum is mass into velocity, but instead of velocity, if it was to be for the speed, the linear momentum of system of particles is sum of linear momentum of the individual particles. Okay, because for speed we know it is a scalar quantity, and then it is saying that the linear momentum of a system of particles is sum of all linear momentum, because then it will have only magnitude and no directions, therefore negative sign will not be there. Okay, then can we state principle of conservation of linear momentum as linear momentum of systems remain constant if no external force acts on it? So can we say that there will be a conservation of linear momentum even if there is no external force acting on it? Okay, so this is the question asking. Can we say conservation of linear momentum will be there if there is no external force? No, it is not necessary. No, it is not necessary that in this situation there will be conservation of linear momentum. It is not necessary. The linear momentum of system remains constant even if does not remain constant even if no external force acts on it, because during collision because during collision the sum of magnitudes of momenta does not remain constant. Sum of magnitudes of momenta does not remain constant. And we know what is momenta. Momenta is basically plural of momentum. Okay, so it is not necessary that there will be a conservation of linear momentum, because we know during collision also sum of magnitudes of momenta does not remain constant, because it is happening at in a very short interval of time at a very high speed. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.